glad you're doing care. It is Mike Levin on Wednesday, February 19th, 2020, on my way into the Emerald City. And this is one of those mornings, a beautiful morning, by the way, where I don't even have to stop to think about what I'm going to talk about. I usually use these videos to think through difficult problems in my life, usually on the professional side, so that when I sit down to implement, when you see me doing the talking head videos, I have thoroughly thought through the problems. And nothing is really a surprise to me that I encounter as I sit down to code. And the type of work that I do, the type of coding and programming that I do, is really process automation, maybe RPA, robotic process automation. And somewhere in that process, there is often data transforms. That is, you can think in terms of data on the left and data on the right. Input data on the left, stuff you're grabbing on the left, and that you're moving over to the right. This two sides or left and right concept often reoccurs in data manipulation procedures. Sometimes there's two things coming in and one going out, where you're doing a join. So it's a union between three sets of data. Although union is a special keyword, by the way. I either limbo under or I go over. I'll choose the under option. There's always lessons about APIs, application program interfaces, or just interfaces in general around us. Oftentimes, when you're exploring possibilities, you think you reached the end, but you didn't really reach the end. You just reached the end of the exposed or easily noticed stuff. And if you explore a little further, push a little further, look for the secret passages and doors, continue going along the wall, you'll find there's much less cut off from you than you might at first imagine. Oftentimes, the good resources are not so much behind locked doors as much as they are just out of the way, security through obscurity. So it's with this attitude that you approach new projects, new learnings, new processes that you need to automate. And for many years, when doing this type of work, it meant SQL. It meant that a SQL database and a particular, usually tender love and care maintained databases in the picture, with database administrators, fairly high-level professionals tending to the life and health of that database, and you as a report generator or whatever it is you're doing that's making you automate data procedures has to connect to that data source. You have to have the credentials to connect to it, and the terminologies vary with the IT systems, but because of Google and OAuth 2, the terminology that's coming into vogue is the one that goes with usually three-legged authentication. There are three parties involved. The people with the data, such as Google, Google Analytics, Google Sheets, anywhere where you might be getting data out of a Google data store. BigQuery is another one. And then there's having the credentials to access that data. Like, I am someone who's supposed to be able to access this. Using those credentials, you become authenticated. And authentication is usually stored in a temporary token that's kept local on your system and is only good for about an hour, then it disappears, and you have to go through getting your authentication to access the data again, given that you still have your credentials. So It inserts places where the data providers can optionally cut you off if the world changes. They just don't re-grant you the key. So your access to any data in any of these web systems is really only as good as Google's or whoever the data host storage facility is, as their willingness to give you back access tokens, giving your credentials. So that's sort of a digression, because in this kind of data work, one of the funny things is that one of the hardest parts in all of this is really getting authentication to access the data, especially in this world of OAuth. Though I was talking about three-legged authentication. One is the people housing the data, one is you, the user, trying to get to the data, and the third is the application that the user is using, because the user isn't right at Google. They're going through some website or some phone app, or maybe it's a server-based script. Now, when it's a server-based script and there's no human there, typically the three-legged authentication is made to look like two-legged authentication, with a service account being there saying, I'm that person, go ahead. And so you have to make your choices about how you're going to access your data persistently over time. It's always easy to do it once sitting there with like a Jupyter notebook, but then to move it over into an automation system needs to deal with all the nuances of re-authenticating and getting a new access token. So anyway, data moves from the left to the right, being drawn from some data system, and then some manipulation happening, some formula being applied. There's a variety of ways it could really go at that point based on what you're trying to do. You could hit a second or a third or a fourth data site and be combining those with field mappings and joins and stuff. But now you have some decisions to make. When you hit these original source APIs, what are you going to do? Drop the data into yet another database so you have a persistent long-term data store where you can retrieve it again? Or is it just like a fragile soap bubble in the computer's memory? When that program stops running and memory is released, is all that data going to just go away? And so that first problem very typically needs to be solved in such data process automations. And being on the Python platform and with the data that you retrieve so often being expressed in something that resides in a fairly standard Python data object, like a dictionary or a list, or even in a memory object that comes from third-party packages like pandas. So your data might be living in a pandas data frame that we so often see with a df variable or reference name. And that should be not like a soap bubble. That should not be about to disappear the moment that script stops running. You want that stuff committed to something. And the easiest thing in Python is to just take that object in memory and drop it onto the hard drive or the storage or whatever have you. If you're on a cloud platform, it's sure to have some limited amount of local storage and you can do it there. But if you're on a Linux platform, an Amazon EC2, a Digital River or whatever, there's a whole bunch of them out there. I probably got that second one wrong, but you know, you're talking about the virtual servers that you can buy, like the Elastic Computing Cloud from Amazon, where you can buy it in increments and stuff. You're working on a regular Linux machine. They often call it infrastructure as a service, capital I, lowercase a, capital S. Infrastructure as a service is a code word for using a very standard generic Linux system, which is really one of the smallest units of digital consumption out there that you can do interesting stuff with, because it gives you a little bit of everything you need to do a job, a little bit of CPU, a little bit of storage space. And so you can use that little bit of storage space for things like this and do away with the need for a database altogether to back-end your application. So when you're doing this process automation, the marketing folks and often the marketing folks and people like them are often going to look at what you're doing and call that, oh, it's back-end automation. It's the type of automation you do where you're not using web user interfaces from vendors and software and service providers. Instead, you're really just, using a unit of computing power that could be anywhere. It could be a Raspberry Pi, it could be local. So it's a more flexible way of working, because your work doesn't have to be hosted at a particular cloud provider by a particular vendor. You have freedom by working at the IaaS, infrastructure as a service level, at which level you have ready access to a local hard drive or something like it. It's probably going to be solid state these days, and but it's going to be heavily backed up in these cloud services. So writing things there is a pretty good practice for later casual retrieval. You probably wouldn't want to base a large database system on this unless the data was files. Then why not use a file system as your system for storing files? File systems are in fact databases. So what we're doing here is when we fetch data from the APIs and are sitting on somewhat valuable soap bubbly data, we throw those objects in memory onto the drive through a process called pickling, which is the serialization of an information structure in memory and data structure in memory into a file that can be written to the drive. And then you plop it on the drive, and then you load that file from the drive back up into memory, and you have your object again. So that certainly gives you object persistence for things like DataFrames and even the original, usually JSON, JavaScript object notation, responses to your queries. So you drop them somewhere, drop, and probably you want to drop them somewhere where you can retrieve them again easily and separate from other days where you did the same process, so that they don't interfere with each other, yet you don't want them to fill up the hard drive. So it's going to be some sort of file or directory creation system, or maybe a little of both, creating directories that, correspond to year and month likely. And inside each month, you drop a file that is possibly the complete pickled contents of everything you're doing in your app. Or alternatively, because there's a lot of ways to manage your pickle data, you can have lots of little pickles representing individual objects, so long as their file names don't conflict dropping onto the drive. So you can use the same file names all the time if your directory names change with a time period. Or if you put the time period in the file name, you can keep dropping them into the same directory for an awful long time, but after time, a single very long directory gets lower performance. It takes longer and longer to access the data out of that location. So some sort of compromise has to be struck. Just like you're always pushing complexity around when you're doing this sort of work, you are also pushing around containerization issues to decide how things get physically separated from each other in a way which usually is not followed up or backed up by hardware, but can easily be made that way. So for example, if you pickle your data into separate files, any of those files can just be copied to an SSD drive, for example, be taken off the server and moved on to another machine, potentially emailed or go through other communication transport systems, and put on physically separate machines. So these are the issues I'm thinking through right now in one of my process automation tasks coming up, where I'm going to have to hit the same data source over and over and over again, cache all that data locally on the drive through pickling or the higher level abstraction of the shelf API. The shelf API helps you manage a lot of these pickling issues by allowing lots of pickles to go into a single shelf. And it's just a light API wrapper to give you some terminology around nested object manipulation. So it's nothing you couldn't cobble together yourself, spin your own shelf system from the pickling system, but Python does come with import shelf. So you import pickle, import shelf, and you can do lots of neat stuff at that stage of storing your JSON responses to your API calls locally. And then a transformation occurs where you use those potentially still in memory, but maybe in a separate task that has been launched, reserialize all those data objects you fetched and artistically shape them into a pandas data frame, a row and column scenario, like a matrix, like so many other systems, tabs in Excel and Google Sheets, tables in SQL, and do all your SQL or Excel-like manipulations. Create new columns, which are derivative columns, formula columns, and construct a X by Y full of cells, object in memory, pickle that, because now you can get back either the original data or what you shaped it into, and then you drop that X by Y data object into potentially Google Sheets, Excel, a SQL table, or any other system that uses these two-dimensional arrays to store their data. Sometimes you have to size things ahead of time so it has somewhere to go, but that's basically it. I'm here at the ferry, and we'll be hopping on in a minute, so I'll wrap this up. And so that's my task today, to think through mostly how I store the original data fetches, how I shape it into a data frame, how I pickle all that, the terms under which I'm gonna make those pickles persist over time, potentially eating its tail so that the server never gets bogged down, and bam, I'm ready to go. I have a magical process automation. And thanks for joining me. Hope to talk to you again soon. Don't forget to subscribe.